Hello and welcome to another video. Today we have an interesting repair on our hands. I got sent two boards from viewer before where he said that this power supply killed two of his boards, and this is now a third one that this power supply killed. So basically what he said that it smelled like something was burning as soon as he tried to plug this one into basically anything. So he thinks that this is damaged. So what we will do, we first will have a look at the motherboard, and then we will have a look if we can find anything wrong with this PSU. But for now, let's focus on the motherboard first. So let's start with our usual checks on this board. So we are going to go for resistance measurements here. So let's start off 3.3 volts, high resistance, 5 VSB, high resistance, 5 volts, high resistance, and 12 volts. That is interesting that it's such a static, like 1.4 kilo ohms. Interesting. Okay, let's go for the 12 volts auxiliary for the CPU, and that is high resistance. And let's check that to the face. I'm going to do that by probing the bottom, and that has also high resistance. Okay, so let's check quickly the battery. Battery has 3.1 volts, so has been replaced. Let's quickly check around on some of these inductors for resistance. So for example, there's a linear regulator right here. Let's check its tab. That looks fine. That is probably 5 volt dual. Then there's a inductor right here, which is probably VDDQ, like 1.2 volts for the DDR. That has high resistance. That is good. Then we have more inductors right here. This is probably 1.05. No, this has high resistance. This must be something else. Then let's check this one. Also kilo ohms, so both nothing special. Okay. Then there's another linear regulator right here. Also kilo ohms. And let's check on the BIOS chip on the 8th pad. That should be 1.8 volts. And that has also... Oh, I wasn't checking it properly. I was still... Yeah. Let's check these inductors again, because I think I was checking them to 12 volts and not to ground. But let's be sure. Yeah, lower ohms here. Lower ohms here. Okay, but I think we're fine to power this up and see how this reacts to anything. So let's put some power into this. So let's see. 750 milliamps. Holy moly. Oh yeah. Oh, I smell something burnt. Whoo. Like 5 VSB wasn't shorted. How was there so much power going into there? Okay, let's check 5 VSB again. Yeah, 5 VSB is not shorted. Wow, how did we get that kind of power consumption? Okay, I would want to check with my power supply what kind of consumption I get when I try to put 5 VSB onto there myself. So, power supply. There's 5 volts on there right now. I'm going to connect this to ground, and we're going to connect it to 5 VSB. Let's see how much... Yeah, 1.5 amps. There's a lot of power going into there. Okay, let me get my thermal camera. So, with that kind of power consumption, we should see this light up like a Christmas tree. So, let's see right here. Need to do it some way where I don't cover anything. But I will cover something. So let me see. Let's do it from this angle. Oh, is it something here heating up? Ha! I think, if I'm seeing it correctly, that's every single USB protection that is lighting up. Yeah. It's all of the USB protection that have blown on this. I've seen this multiple times already. Have a good look. This is the bottom of the board. It's kind of hard to see. Let's zoom down, because we know now where we're looking at. And let's get that light out of here. So, we're looking at this general area right here. And have a look now when I connect this. what lights up. These right here. And we can see the same right here. All of the USB protection circuits are blown. This might be that there was like 12 volts put down into 5 volts. And that is not a big problem, actually. All of these are quite easy to remove. Like, I've done that multiple times. And removing them isn't a big thing, to be honest. So, let's move under the microscope. And I'm going to show you how I remove these and how you can easily remove them, basically. So, let's go under the microscope. So, right here we have our specimen. One of them, at least. And all we're going to do now is we're going to add flux to it. I'm going to flux the other ones up as well. And what we need is a knife tip. Kind of like this one you can see. Let's turn on the soldering iron. And all we do is we're just going to be adding solder to both sides of this now. Like that here. And like that here. And now we're just going to do that. Just heating up both sides and removing it. And that's all you do. No hot air needed, nothing. Just quickly removed, and the USB port next to it didn't get damaged at all. And we're going to do the same thing for these ones as well. Now the front panel headers are done. We are moving to the headers for the back I/O. And we're just going to do the exact same thing here. Just a different angle, but exactly the same thing that we're doing here. So I think I got all of them removed. So this was like, I think 6, 1, 2, 3, 4, 5, 6, 7, 8, 9 even. Okay, well then, we're going to go over to the overhead then once more and we're going to have a look. Okay, let me see if we still have power consumption on 5VSP that high. No, 60 milliamps, now it's fine, okay. So, going back to plugging in our actual adapter here. So let's see. And there we are, 60 milliamps. That is what we want to see. So we found a short already. So all of those were shorted on here. And now the interesting question is, do we have some voltages already? Is anything like booted up by now? So let's see. 5-volt dual at the top right. There. Then let's see. 105, probably not. 108. 108 might be a problem because I'm checking on the BIOS chip, and the 8th pin of a BIOS chip is most of the time, or basically always, the VCC pin, and there's nothing. But it might be that only with the CPU that starts up. 3.3 volt looks fine for the PCIe slot, and basically nothing much more that I can check. So let's get a CPU into here and then check again with that. So let's see, let me get my 2200G in here, turning off the power for that. 115 milliamps, that looks good. And now with 1 stick of RAM, I would be very interested how this behaves. Now it might be that this was already all that we have as a problem. So let me plug in HDMI here. I'm going to put a cooler onto there. Let's see if this even has a reaction to the power button, because it might not. Like, who knows what actually happened to this. So let's we can also get a speaker, and let's put just a power button, a regular one, on here instead of shorting it. So power button on here. Let's check it. Pressing the power button. 2.4 amps. That looks very fine. 2.2, okay. Let's see, do I have my post screen enabled? It is enabled. So, oh, a post beep. That is very good. Is this complaining about VGA? Seems like it. Let's see, do we get a picture? This is a 2200G, so it should have VGA support. Is this on already? Because it might be. It feels like this is on already. Yes, it is on already. How I can tell is by the numlock working. So, no real idea how that can be that I don't get a don't get a capture here, but that isn't a problem. Let's just prop this up. Let's put the second stick of RAM into here and then get a GPU also into here and try to capture from that. So now with a dedicated GPU in here, let's try this again. 5 amps, beeps. Let's see, give me a picture. Give me a picture. I think something with my capturing is wrong. Yep, I have to check for my capture card. Something there is not like it's supposed to be. And there we are. I just had a problem with my capture. So it probably even posted via the internal HDMI. And there it is. Now it's working fine. Okay, very good. So this was a simple fault that the 5-way VSB got dragged down massively by shorted components of the USB protection side. So all of that was working. Like, I checked the USB as well. They are working now because obviously I plugged in my USB keyboard to see the caps lock reaction. So let's now then go over to the PSU. Can't really promise anything if we are being able to do much there, but I at least want to analyze a little bit of what is happening with it and if there's like anything properly happening with it or not. So here we now have the power supply, and I have a breakout board right here that takes the 24-pin adapter and then adapts it to all of the voltages. As you can see, it's upside down, but 3.3 volts, ground, 5 volts, ground, 12 volts, ground, minus 12 volts. I think the only real missing is like the 5 VSB on here. I just want to see how this reacts when I attach it. So let me push the power button. So this thing has power. Let's short the piece on. And it does turn on normally. Okay. Did it turn on or did it trip? Not really sure. Let's check if there's any voltage on here. Because it briefly the fan spun and then nothing. Let's see. No, I don't think so. Yeah, it shortly booted and then nothing. Okay. So this thing has definitely tripped then. So we will have to proceed differently. Let's cycle this. So we're going to turn this off. Then let's put this in here again. So let's see. The power supply is on now. I now need to find the place where the PS on is on this. And now I always think about how I plug this into my motherboard. And then I take the pin 3 and 4. And I should have 5 volts there. And we have 5 volts on pin 3 and 4 from there. That means we have the PS on. Let's check. This should be 5 VSB, I think. Yeah, 5 VSB is also fine. Interesting. So the 5 VSB and also the 5 volts PS on are both fine. Interesting. So we don't have a problem with that for now. Let's see. Let's unplug the auxiliary power cable. And let's connect my tester again and see if it behaves the same way when we try to short this. So this now shorts the PS on to ground. And it shortly turned on and then off. And we don't have any voltages anymore, right? Yeah, no voltages anymore. So we turn this off. Let's check if the power supply went into some kind of protection mode. So we're going to check pin 3 and 4 again, that we usually short for PS on. Let's see. And PS on still has 5 volts. Okay. And does the 5 VSB still have 5 volts? The 5 VSB still has 5 volts. Interesting. Okay, let's plug this in. Let's see if my multimeter is quick enough. I want to probe like the 12 volts. Let's see if we get a glimpse of 12 volts here. Yeah, we did. As you can see, we saw just 12 volts there. Okay, let's see. Next is 5 volts. Let's check 5 volts. And that went to 4.6. That looks also fine. Let's check 3.3 volts. And 3.3 volts, I think, stayed 0. Yeah, 3.3 volts, as you can see, stays 0. Nothing. Yep. And all of the other voltages, I get something when I turn this on. So this probably turns itself off because 3.3 volts isn't running. Oh, but I think I know the problem. Yeah, there's something wrong here. Have a look at what I'm doing now. I'm going to put my multimeter into max mode and min mode. I'm currently on 5 volts. You can see 5 volts in ground. And now I'm going to turn this on. Okay, this was now 4.9. Let's try this again. 8.3. The 5 volts seems to be shorted to the 12 volts. So let's check that. 5 volts and 12 volts. Interesting, this might... No, it's shorted. Okay, this might be a wrong cable on this. He said that this was the cable that came with it. I'm not sure if I can trust that. Okay, this is now a little bit difficult. I have to pin this out. Like, let me search. What I'm going to do, we know this pin out, the 24 pin. Like, we know what this is supposed to be. And I'm going to try to find them on here. What I'm going to try first is going to find the PS on and a ground. And then I want to short them in there without a cable and see if the same happens. So, one probe here. Let me see. Okay, I have one probe in there. Let me see if I can find the PS on here, on these cables, because these pinouts, as far as I know, are not public. So let me see. So I found a pin. So on the bigger one, the fourth one to the right has that. Okay, let's see if the one next to it is also ground. Okay, those don't appear to be ground. Which of these is ground? Is the ground completely on the other connector? So I found a single ground on the other connector, which is kind of weird. So top left seems to be ground, and the fourth one from this one seems to be PS on. Let's check that on the power supply. If we get like if we see 5 volts for the PS on here. So I think let's go into voltage mode. If I remember correctly, let me see right here. It's supposed to be this one, and what is it, this one? Yeah, 5 volts. Okay, let me show you. So if anyone wants to cross-reference that. So the PS on is from this one. the 4th pin, and then it was this one, I think. Yeah, that is a ground. So the 4th one there, and this one is a ground. So we want to short these two out and want to see what happens with the power supply. So what I'm going to do, I'm going to go into amperage mode with my power supply. I'm going to put this into 20 amps, and we're going to short this with my power supply and see what happens. So the fan spins on and goes off. So it's not wrong cables. This thing is properly shorted. So there's an actual problem with the 5 volts being shorted to the 12 volts. So the cable is not at fault here. This is just basically a power supply failure. So opening up power supplies is really dangerous because there are high voltage capacitors that store like up to 400 volts or like 450 volts sometimes. Do not copy this. I do not recommend this. I know where I can touch and I know where to keep my hands off. This is just for entertainment only. So I want to at least see if we can find anything here. Like, we don't need to repair it because this is like the RM550 from Corsair is a nice power supply, but like it's most of the time not worth repairing these because also the question is for reliability of these. So let me take this apart. And now we have the power supply out. And I would expect that some of the MOSFETs have blown on here. Let me take out this board. So careful when you open these up. The capacitors have really high voltage on them. And they are going to discharge and they are going to hurt if you hit their voltage. So I got to be honest, I haven't seen one of these RM550s blow before. In my opinion, they are mostly really reliable ones. That are like that I could always recommend. So this is a first for me, seeing that one of these failed. So I don't really have any experience in capturing like power supply repairs. Let me see what I can do so that you can see better what I'm actually doing here. So I'm going to be cutting the AC terminals, I think. Yeah, I'm just going to cut the AC terminals because I do not want to deal with this, desoldering it all and then resoldering. I'm just going to cut the wires and resolder those wires if needed. So let's get rid of that. Because, yeah, like I said, I'm not really sure if we are even going to fix this. So, where to begin? Let's just see visually a little bit on here. So this is the faceplate of it. And here everything looks fine. Like nothing visually bad. Let's see on the back side here. Let's zoom down. Oh, this is the most we can zoom down. Let me lift this up. Let's see. Nothing charred. Nothing burned. Everything looking fine. So if I understand correctly, how these work is that they mainly produce 12 volts from this main transformer right here. And then they're stepping it down to 5 volts and 3.3 volts with auxiliary power supplies like these ones right here that you can see. This might be an EMI filter, to be honest, because I see capacitors and common mode chokes mostly. And yeah, it might be derived from this, but it might also be coming from this side right here. So I spent some time tracing out 12 volts and 5 volts and have a look right here. So from this one to there, I have 10 ohms. So this one is 12 volts and this one is 5 volts. And we see 10 ohms. And what I want to do, I want to get the thermal camera again. And I want to inject voltage into one side and connect the ground to the other side. And hopefully, we're going to see whatever connects those both together. Like, I've never done this before, but in my head, it makes sense. So I will be starting low with just 1 volt. Let me see if I can connect these in a way where there's actually current flowing. 10 milliamps. That will be hard to spot, but we can go higher. I might want to solder wires onto here in order to be able to connect this properly. So what I will do, I will beep out the bottom side of the board, and I will try to find 5 volts and 12 volts in order to be able to solder just to them. So I now have breakout wires. You can see 2 wires, and if we check their resistance to each other, we can see 10 ohms. Okay, so this is now where we can inject our voltage. So let's connect these. We have 10 milliamps of power consumption at 1 volt. Now let's see if the P2 Pro can show us that. So let me see. Probably without the macro lens first. And the only place I can see a little bit of heat is somewhere here. This is like the faceplate where I'm currently looking. But this might be because I just soldered wires there. So I think I need to go higher with the voltage. The maximum I want to go for is 5 volts. So let's go for 2 volts now. Because I also cannot see anything particular heating up here. Is this... No way this is like a short from a capacitor. I don't think so. But currently I cannot spot anything. Let me have a look around if I can see anything that looks suspicious to me. Because there are many subboards on here. And if there's a MOSFET shorted anywhere here, like 2 volts will be very little. And I think I can see MOSFETs that are shorted. Yeah, right there. I think I can see them. Let me zoom down so we can get onto the same page. I just wanted to search for it myself. But right here, we can now see there's a subboard where the main transformer, I think, comes in. No, this is I think this is the filter board where this runs on. And I can see some heat down there. Let me up this to 3 volts. And yeah, this goes higher with my power, I think. Like, the power probably travels through the front board. That's why we see it. But, like, the main issue is somewhere there. Like, something on the subboard is shorted. Yeah. So, I will have to desolder this thing right here. So, where we're looking at is this thing. And at the bottom there, something is getting hot. So, we will definitely have to desolder this. And from there, then see. I'm already telling you, I'm not planning on pretty much fixing this. I just want to know the cause of what has happened here, or what could be faulty here. So let me see if I can somehow unsolder that thing. But that looks quite difficult, to be honest. But I will try. I will not record that because that will take quite some time for me to get that thing out. So I'm gonna do that off camera. So I got the board out. You can see like parts of it here. And this contains mostly transistors. Like, we almost have exclusively MOSFETs on here. With the microscope, it's almost like too close. But let's check each individual transistor here. So we're going to check between the two incoming signals of it. And I cannot get a shot on this one. Let's see for this transistor right here. No short here. Let's see if there's a diode is shorted, but it shouldn't be. So let's see. Then there's another one right here. Let's check these. And this is shorted. I'm pretty sure this is our culprit then. And this is not shorted. Then this is not shorted. Oh, you can see this one also not shorted. And another one right here. Let's see. Also not shorted. So, and the main controller looks to be fine, I think. Like, the biggest problem, while I was getting these out, I pulled pads. As you can see right there, I pulled a lot of pads right there. So, the culprit, how this failed, was a single transistor right here that has gone short. Let's try to remove it and see if then the short disappears and stays on the MOSFET. So let's remove that. And let me first, before I do that, apply leaded solder to all of its parts, because it's going to lower the melting points significantly of it and making it easier for us to remove it. So that took a lot of heat, but the transistor is out. So let's check these parts if they are still shorted. Let's see, which two parts? These two. So that part and that part was shorted before. Let's see now. And no, nothing anymore. So this short probably stayed on the transistor. Let's get the transistor onto here. And let's check this now. And let's check. It is shorted. And that is what happened with our board here. And most likely, it not only killed that, but it probably also killed the controller that is on here. So, this is all I wanted to do, to be perfectly honest. I was basically only curious to what has happened to this, why this has failed. I'm not going to repair that. I'm not going to replace that MOSFET because I do not know what else failed on this. I know this might be like really sad for some people to see because they wouldn't want to see it, but this is just a risk. Like, repairing power supplies, if you don't know what you're doing like I do, is really risky. Because pretty surely there's more damage than just this one. Because we also didn't see the 3.3 volts firing up. It might be that the 3.3 volts was powered by the 5 volts, and that's why we didn't see 3.3 volts. But most likely the controller also needs to be replaced on here. Like often that we do when we have a short on a MOSFET on VRM circuits, we also replace the driver. And in this case, I cannot replace the driver because it's that big chip. And yeah, this power supply isn't really worth much money. But for me, I wanted to know what has happened to this, and we definitely have figured out what has happened. There's an N-channel MOSFET that had shorted the 12 volts to the 5 volts, and that's also why motherboards kept on dying, because the 5 volts got supplied with 12 volts for a very short time before the protection circuitry kicked in. So yeah, that's what we learned with this one. I'm going to throw this away or keep it as spare parts. Perfectly honest with you. I do not want to test this with like putting an actual MOSFET into here again and then blowing something else up. I know this is a sad way for this to end, but this is how I'm going to end it. What might be actually a thing is that this works on 12 volts now. That all of what this does is take 12 volts, put 3.3 volts to it, and put 5 volts to it, and then supply it. I think the rest of it all does 12 volts, and the 12 volts might still be coming out of the front there, but I'm gonna be honest, I do not want to deal with that. That is like power supply territory is nothing I feel great about doing or feel comfortable about doing. But yeah, just the DC side, seeing for what was going wrong, I was comfortable with that. So, thank you very much for watching. I hope you enjoyed this repair. Hope you enjoyed the repair for the motherboard as well, and we could shine some light why all of these things happened. And if you want to get one of these current meters, with which I was instantly able to tell that something was wrong as soon as the 5-USB was connected, email me. And yeah, all of my tools are linked in the video description. This was Mainboard Medic. Thank you very much, and goodbye.